Hi guys, Miss O'Connell here. So I got an email about a question concerning how to find the total displacement once you take the integral of a velocity or acceleration equation. So I'm just going to talk about quickly what an integral is, and then I'm going to do an example. So the videos that were kind of linked in the summer packet explain what an integral is, but we're going to talk about how you'd find the displacement from that. We're going to review this again the first week of school. So again, I just want you to try your best on the last couple pages there, so pages 20 and 21 with the integrals. So for those of you who are unfamiliar, basically what an integral is, it's a shortcut to adding. So basically an integral, you add up the area underneath a graph. Okay, so for example, I'm going to draw a nice velocity versus time graph. Okay, so this velocity versus time graph, it starts at 0, 0. Velocity increases, okay, and then it kind of fluctuates a little bit. So let's say that we were asked to find the distance that an object travels based on this graph. We could isolate a few points. So specific velocities at specific times, and we can figure out the displacement. Okay, so we'd be able to find the displacement or the distance at 1, 2, 3, 4 points, right? But we see that there are spaces in between those points. So we could cut those segments in half again, find the distance displacement at 8 points, add them up to figure out the total distance. That would take an increasingly long amount of time. So what we do is we call it integrating. And what we do is we basically eliminate the spaces between those segments on the velocity versus time graph. And what we're doing in theory is basically finding the area under the curve. Okay, excuse my handwriting here, I'm trying to use a stylus. So you find the area under the curve. We're talking about velocity. The area under that curve is the displacement, so how far that object travels in a given amount of time. So again, we'll go into this a little bit more in depth and in detail when we get to back to school next week. So when we have a velocity graph or velocity function, we can find displacement. So velocity is the rate of change of displacement over time, right? Well, how we've been writing this in the past is velocity is change in delta x over change in time. Basically, we eliminate that delta with a very small d, meaning an extraordinarily small amount of change. Right, there is no space between these points on the velocity versus time graph in which we are developing what the displacement is. So velocity is change in displacement over change in time, dx dt. Okay, so to find our displacement, we have to take the integral, or the area, of our velocity function or graph in terms of time. How we write that in terms of calculus is velocity times dt. So we're taking the integral of the velocity function in terms of time, which I believe from the videos you should be able to do. So I'm going to take a look at on page number 20, number 1. Okay, so let me scroll down and give us some room here. That function that we're given for velocity is 5t plus 20. We want to find the displacement. We know that displacement is the integral of the velocity function in terms of time. So I'm going to substitute that v in that equation in for the actual function that we're given. So I'll have the integral of 5t plus 20 dt. So the integral of this function in terms of t only. Okay, so to integrate here, right, I'm going to take t to the n plus 1 and divide by n plus 1. So I'm going to write out all the steps here. So I'm going to have 5 times t to the 1 plus 1 divided by 1 plus 1. Okay, that dt applies to both terms, just like distribution in algebra. So I'm going to have plus 20 t to the 0. Oh, that's awful, hold on. Plus 1 divided by 0 plus 1. So let's simplify. So t to the 1 plus 1 plus 1 is 2, I'm going to have t squared. So I'm going to have 5 over 2 t squared plus 20, 0 plus 1 I get 1, so I'm going to have 20 t to the first, or just 20 plus t. Okay, so basically we integrated that velocity function in terms of t to get our displacement equation. Oh boy, this stylus is not good. Excuse me, guys. Okay, so that's our displacement equation. If we want the total displacement from the time interval of 0 seconds to 2 seconds, we want to find something called the definite integral, which would basically mean the definite displacement from 0 to 2 seconds. So what I do, okay, is basically, theoretically, I plug in a 0 for t and a 2 for t. How that looks, okay, in terms of calculus notation, is I'm taking the integral of v dt. That's not working. There we go. Of v dt from 0 to 2 seconds. Again, I plug in that v value, which we kind of already did the math for, but I'm going to show you again. So I have the integral of 0 to 2. Equation for v is 5t plus 20 dt. So I'm going to evaluate this integral from 0 to 2. The solution to this integral, we already did the math above, is 5 halves t squared plus 20t. We're evaluating this function from 0 to 2 seconds. So we're going to plug in for t equals 0 and t equals 2. 0 is our lower limit. And 2 is our upper limit. So first we're going to plug in 2 for t. So I have 5 halves times t squared, so replace that t with a 2, so 5/2 times 2 squared, plus 20 times 2. So I plug in my upper limit for t, and I want to subtract the lower limit. So I'm going to subtract 5/2 times 0 plus 20 times 0, which gives us a big fat 0. Write this whole thing here. Anything times 0 is 0, so I'm going to get this quantity here on the left minus 0. So just simple math here. I'm going to have 2 squared, I get 4. 4 times 5, I get 20. 20 divided by 2, I get 10. Plus 2 times 20, I get 40. Minus 0. My final answer is 50 meters. Right, because this whole thing is equal to x. So this technically is my total displacement. So from 0 to 2 seconds, my object's going to move 50 meters. Okay, so again, the question was, how do you get the total displacement after you find the displacement equation? You plug in the limits that they give you. You do upper limit minus lower limit. So you take the equation, you plug in 2 for t, and then you subtract the equation evaluated at 0 seconds. So basically, you'll have your function minus 0. Okay, and the units are meters because we are looking at displacement. Okay, if we have any additional questions, please send me an email. For acceleration, you're going to want to do the same basic process. Okay, and what that would look like. You know that the acceleration, a, is equal to the derivative of velocity in respect to time. So to get velocity from acceleration, I'm going to integrate the equation or the function they give you for a in terms of dt. Then you'll want to evaluate from 0 to 2 seconds, like we did in the previous example.